So what is the fundamental difference between nonlinear and linear systems that is the reason why nonlinear systems may display much more complex behavior than linear systems can? The fundamental reason is that for linear ordinary differential equations, the superposition principle holds. The superposition principle can be stated in several alternative ways, and one way to formulate it is in terms of linear electric circuits, saying that the response to several inputs working together is equal to the sum of the response of that circuit to the inputs working separately. Another more general formulation of the superposition principle is that if an input U1 to the system produces an output Y1, and another input U2 produces an output Y2, then the sum of the inputs will produce the sum of the outputs. This is the reason why, when working with linear systems, you are used to being able to express the systems with block diagrams in this form here. We have one block representing the system response to the control input U, and we typically call the corresponding transfer function P for process of S. And then we have another block representing the system response to disturbances, V. And the corresponding transfer function is often denoted HV of S. The output of the first block is the system's response to the control input, and let's call this Y1. And the output of the other block here is the system's response to disturbances. Let's call this Y2. And as you remember, we sum these two to get the system output Y. The structure of this block diagram expresses the superposition principle. The control input, U, which we may call U1, produces an output Y1. And the disturbance input, V, which we may call U2, produces an output Y2. And the system response to these two inputs is the sum of the two outputs, Y. And then we typically feed back the output, compare it with a reference signal, and design a controller to make the system follow the reference and suppress the impact of the disturbance as well as possible. For nonlinear systems, however, the superposition principle does not hold. While for linear systems, the system behavior is the sum of each component's behavior, the system behavior is more than the sum of each component's behavior for nonlinear systems. Something which relates to the thoughts of Aristotle's metaphysics of the whole being more than the sum of the parts, and this leads to much more complex behavior than what linear systems can produce. An analog of this difference is found in Leo Tolstoy's Anna Karenina, which says that all happy families are alike. Each unhappy family is unhappy in its own way. A slight adaptation of this that holds for our case is that all linear systems are alike. Each nonlinear system is nonlinear in its own way. So for nonlinear systems, there is no one-size-fits-all, no one method fits all systems. Nonlinear systems may display many different kinds of complex behavior, and we need to get to know the system profoundly to design a good controller for it.